In this webisode, we'll discuss modeling in the next generation science standards. The new standards emphasize modeling throughout the performance expectations and expect that models be used to explain, explore, and predict scientific phenomena. For example, here are some next generation performance expectations pertaining to scientific modeling. In 5th grade, a core concept is matter and energy in organisms and ecosystems. 2 of the 3 expectations within this concept are use models to describe that energy in animals' food was once energy from the sun, and develop a model to describe the movement of matter among plants, animals, decomposers, and the environment. In middle school, a core concept is structure and properties of matter. Again, 2 of the 3 expectations within this concept are develop models to describe the atomic composition of simple molecules and extended structures, and develop a model that predicts and describes changes in particle motion, temperature, and state of a pure substance when thermal energy is added or removed. Let's begin by clarifying what scientific models are. There are 2 classifications of models, conceptual models and mental models. Conceptual models are those used to express and explain phenomena. They're the models incorporated into lesson plans, textbooks, classroom demonstrations, and interactive activities. Examples of conceptual models are found throughout the science disciplines. For example, in the life sciences, models pertaining to photosynthesis are combined with food chains and food webs to discuss aspects of ecology. Cell diagrams and models of the human body are common for anatomy and physiology. Mitosis and meiosis are models for cellular reproduction, and natural selection is a model used to discuss evolution. In the physical sciences, models of the atom and particle theory of matter are common for chemistry and physics, as are models of electromagnetic phenomena, energy, and electricity. In earth science, naturally occurring phenomena such as weathering, erosion, plate tectonics, and volcanism are commonly taught with models. And in space science, models of the lunar cycle and solar system are commonly used. Mental models are those that are internalized by students. The goal in science education is to use the conceptual models to strengthen students' mental models. Once students have solid mental models about how the natural world operates, they are able to apply those models to make predictions and offer explanations about phenomena. Looking back at the examples of 5th grade performance expectations, food webs and energy pyramids are excellent models for discussing matter and energy in ecosystems. Food webs model the flow of energy through an ecosystem by showing which animal consumes which. Energy pyramids highlight the amount of matter, or biomass, at each trophic level of an ecosystem. These models are useful illustrations for conveying material to students, but they are also easy to develop and construct as student activities. For example, students may be asked to compose a list of organisms from their local ecosystem. Once representative samples of producers, primary, secondary, and tertiary consumers are identified, students may be asked to construct a food web or energy pyramid with those organisms. In addition to developing and constructing such models, students are expected to use models to make predictions and offer explanations. For example, students may be asked to use the Alaskan food web model to answer the following questions. What will most likely happen to the kittiwake population if the sand lance population goes extinct? And which other organisms would likely be affected by sand lance extinction? A reasonable response would be to predict a rapid decline in the kittiwake population, leading to adverse effects on the fox, rat, and gull populations. Returning to the middle school performance expectations about the structure and properties of matter, having good mental models of particle and kinetic theories are keys to understanding myriad natural phenomena. Models that illustrate the relationship between temperature and the kinetic energy of matter at the particle level helps develop such mental models. Once students have a good mental model regarding the basics of kinetic theory, the model may be used to explain phenomena that students observe every day, such as gas systems. Students may be asked, what happens to air molecules inside a car's tire when they are heated? Use your answer to explain why tire pressure increases after a car travels several miles. Or weather systems. What happens to the speed of water molecules when they evaporate? Use your answer to explain why water must absorb energy to evaporate. ATI's dialogue technology can help with scientific modeling. Instructional dialogues allow teachers to link lessons to specific performance expectations. The models may be integrated into the lessons in several different ways. This is an example of an ATI instructional dialogue. Galileo technology makes it easy to incorporate models into lessons. For example, if a teacher is planning a lesson about the solar system, showing a model of a solar system would be a good thing to include. To load a model, simply select the type of media you want to display, load the image, and save. While static images are nice models, we believe it is more effective to engage students with interactive technology whenever possible. ATI has created numerous dialogue resources available for teachers to use as interactive models in their lessons. For example, after some instruction about the planets in our solar system, an interactive exercise may be included as a resource. This interactive model allows students to drag and drop the planets into their correct positions in the solar system. Perhaps the lesson is about matter and energy in ecosystems. With ATI's Building Food Chains resource, students can drag and drop organisms into their correct positions in a food chain. In addition to drag and drop modeling, ATI has developed several animated models too. For example, if a teacher is trying to teach the particle theory of matter, showing the relationship between temperature and kinetic energy is best displayed as an animation so that students get a sense of the speed and motion of particles at different temperatures. These types of resources are available for any teacher to use. Here are some more examples. This resource models the skeletal system, and it's another example of a mouse-driven model. Students roll the mouse over the different bones to learn the anatomical terms. Each bone, or sets of bones, also acts as a clickable button. If the student clicks on a bone, they are taken to another page with more information about the structure. This type of model allows students to freely explore the skeletal system in a nonlinear fashion. The weather map model utilizes similar technology. Students roll the mouse over the different symbols to learn about them, then move on to the next slide and use drag and drop functionality to build some weather maps. The forecast says that Phoenix will be under high pressure, resulting in sunny skies. Therefore, the student should drag and drop the appropriate symbols to Phoenix and click the check button. There are multiple forecasts to complete, and they become more complex. The meiosis model uses an animated video to model the process of meiosis. Students simply click play and watch the video. In addition to using models as instructional resources, dialogues also allow models to be incorporated directly into formative questions created by the teacher. Incorporating models into dialogue questions has a couple of advantages. Student response data gets recorded by Galileo, and the system allows feedback for each response so that students are given help when they answer incorrectly. Immediate feedback for incorrect responses has the ability to enhance learning. The primary advantage of dialogue technology pertains to collaboration. Not only collaboration among ATI and our clients, but among teachers and administrators within your district. With instructional dialogues, models and other resources are shared throughout the district. If one teacher creates a conceptual model that enhances students' understanding of natural phenomena, that model may be shared by other teachers throughout the school or district, making it easy to ensure that every teacher has access to the most effective models. If one teacher creates a dialogue that elevates student achievement on a particular performance expectation, then that data will be readily available to teachers and administrators. Such a dialogue may then be shared with every student in the district, potentially elevating district-wide assessment scores. The examples shown in this webisode represent only a few of the modeling resources that ATI has available. We have several more available right now, and there are always more in development.